Hey, welcome. Today we're looking at 2-12 polynomial graphs. So what we're going to be doing today in the first part is we're just going to be matching. So you're going to be using our what we know about our function to figure out which graph matches it. So one of the most important things is to be able to find the zeros here. So we're going to determine the zeros, and that means that we're going to be factoring if we need to. So we kind of covered this a few weeks ago, how to find the zeros from polynomials. So what we're going to be doing is we're going to be using this idea of zeros and factoring to figure out which graph matches. Also, we're going to be determining the degree. So remember from the last time, the degree means the largest exponent. And then the sign of the leading term. So these two things will help us to determine the end behavior. So using the end behavior and the zeros, we're going to find which one matches closest, and then we're going to select that one. So let's kind of look at our first example here. Okay, so we have two different functions and we're going to choose which one matches. So if we look at the first one, f of x equals negative 3x plus 1, x squared minus 4, right? So f of x. So let's kind of talk about this. So the first thing we said we're going to do is find the factors. So luckily it's already factored for us. We have the x plus 1 and x squared minus 4. So x plus 1, the 0 is going to be at negative 1, right? Because negative 1 plus 1 is equal to 0. Now the second one, we are going to have to solve it a little bit, right? Because it's x squared minus 4. It's not just x minus 4. So we're going to say x squared minus 4 equals 0. Then we're going to add our 4. And then x squared equals 4. And then when we take our square root, remember we said that anytime we square root from now on in algebra, that we have a positive and negative 2. So we have zeros at 1, 2, and negative 2. Right, so we have our zeros. Now let's determine our end behavior. So remember we said that last time if we have weird ones where it's already factored, what we're going to do is we're going to take the leading terms. So let's change colors here. So you have x squared, x, and negative 3. So we're going to multiply those all together. So x squared times x is x cubed, times negative 3 is negative 3x cubed. Oh, maybe it's hard to see there. Let's change colors. Negative 3x cubed. So what we know about this is the third power, the exponent, is going to be an odd, and it's also a negative. So we know the end behavior for an odd negative from last time is rising to the left and falling to the right. Okay, so already we can take a look at this and determine that just because we have the negative 3x squared, odd negative, rising to the left, falling to the right, this is out, right? That's rising, rising. This is falling, rising. This one's okay, C is okay because it's rising, falling. D is okay, it's rising, falling, and these two are out. So of these two, we have to determine which one fits the 0. So this one has 3 zeros at negative 1, at positive 2, and at negative 2. So we know that graph D would be the correct selection for this one. Also, if you look at this one, right, we have a 0 at positive 2. We have a 0 at negative 1, but we don't have that other 0 at negative 2, so we know this one is out. All right, so our selection for the first, for the f of x would be graph D. Okay, so let's erase this again here and try the next one. Okay, so for for g of x, g of x is negative 4x to the fourth plus 8x cubed. Okay, so what we're going to do here is we're going to factor out what's common, right? We don't have a constant term here, and we only have two terms, 4x to the fourth and 8x to the third. So what we're going to do, I like to factor out if we have a negative in front, factor out that negative. So because 4 and 8 are both divisible by 4, I can divide out negative 4. And then both of these have x's, so I can take out as many as 3 x's from both of them, right? Because if I took out 4, we wouldn't have enough from the 8x cubed. So I'm going to take out x cubed. And then we're going to put the leftover. So from the front part, we took out the negative 4. We took out 3 of the x's, so we just have an x left. And then the last part, remember when we factor out, we're actually dividing the number. So it's 8 divided by our negative 4, which is negative 2. And there's no more x's because we took all our x's out from the x cubed. Okay, so now it's in factored form. Now we can determine our zeros, right? So we have a 0 here. So what minus 2 is equal to 0? That would be 2. And then this part, it's not in parentheses, but we can think of it as if it were in parentheses. But really, when we have just one thing out there, there's no pluses or minuses. The thing that's going to make this whole thing 0 is when x is 0. So we have 2 zeros, 1 at 2, 1 at 0. And then if we look at the very beginning one, the one we started with, negative 4x4 plus 8x cubed, our leading term is negative 4x to the fourth. This is an even negative. So we know that our end behavior would be falling, falling. All right, so let's look at the ones that are falling, falling. So graph F and graph E are falling, falling. These are all out already. Okay, of those two, which one has the zeros at 2 and 0? So this one is at 2 and 0. This one is also at 2 and 0. Is it? It's hard to see. So we're kind of stuck here. That's odd. Huh. It's weird they make a question like that. All right, so let's kind of go over here and see if we can find any points. Here, I know what they're doing. So remember when we talked about intercepts and factors? Well, anytime we have, let's go here to red. So let's say we had x minus 2 squared. Anytime we have an even multiplicity, meaning that the factor in parentheses is an even exponent, then we'd have a bounce. So this is a bounce. Anytime we have an odd, like this one we assume to be to the first power, right? Even though there's no exponent in this. This would be, it would go through the graph. All right, so let's look over here. For this one, we have an odd for our 0, right? Because that was our 0, 0. And then we have an odd again for our 2. So both of those should pass through the graph. So if we look here, this one passes through the graph, this one passes through the graph. So this would be the one we select. We wouldn't select it because this one bounces off the graph at these 2 points. It doesn't cross over to the other side. So if they were both evens, if it were 4x squared, x minus 2 squared, then this would be the graph because it bounces, because these two exponents are even. So a little bit weird, a little bit more difficult than the first one, but still doable. All right, let's just try another one, just so we can get more practice. So if we look at f of x equals 2x cubed minus 4x squared minus 6. Okay, this one we're going to eventually have to factor, but because we're already in this form, let's go ahead and look at the leading term. The leading term is positive, and the degree is odd. So this is odd, positive. And if we have an odd positive, we know we have falling, rising. Okay, so for all of these, this one's out, this one's out, this one's out, this one's out. Okay? Now let's go ahead and factor. One big hint here is if we have common factors between our leading coefficients, or our coefficients, I should say, 2, 4, and 6, let's divide that out by our common factor. So we're going to divide out our 2. So we have an x, sorry. So we're going to definitely divide out that 2, but also because each of them have an x, let's divide out that x too. So then inside of our parentheses from the first part, we took out the 2, we took out one of the x's, so we have x squared. And then from the second part, we're going to divide out the negative 4 by 2, so that's negative 2. We took out one of the x's, so that's x. And then the last one, we took out the 2 from the negative 6, so it's negative 6 divided by 2 is negative 3. And then we took out the x, so there's no more x's. Okay, so from here, we're going to factor, x squared minus 2x minus 3. So that one's a pretty easy one to do. There's no leading term in front of a leading coefficient in front of our x squared term. So all we're looking for is what multiplies to get negative 3, adds to get negative 2. So that would be negative 3 and positive 1. Now checking here for our zeros. Now that it's factored, 2 times 0 is 0. 3 minus 3 is 0. Negative 1 plus 1 is 0. So we're looking for, between these two choices that we have left, which ones of those has zeros at 0, 3, and negative 1. So this one has a 0, 3, negative 1. Good, let's check this one. This one has it at 3 and negative 1, but not at 0. So we know that this graph A is our selection. Okay, so let's erase this and do H. Okay, so for H, we have negative x minus 4 cubed x minus 1. Okay, because it's already factored, let's find our zeros. Zeros are at 4 minus 4 is 0, and 1 minus 1 is 0. Okay, and let's figure out our leading term. So we have this cubed with our x. So x cubed is x cubed times 1 more x is x to the 4th, and our sign is negative. So we're looking at negative x to the 4th. So what we know about this is that it's an even and a negative. So we know if we have an even and negative, we have a falling, falling. So let's cross out all the ones that are not falling, falling, left and right. Now of these two, which one has intercepts at 4 and 1? Well, this one has at 4 and 1. This one also has intercepts at 4 and 1. But now let's go back to the 0. So this is an odd. This one doesn't have an exponent, but it would be 1, so that would be odd. So because they're both odd, that means at both of those points, the graph crosses through the x-axis. So notice this one, at both points, it bounces back down. So it comes up, hits the graph, bounces down, then comes back up, hits the graph, bounces down. So this one is not the one we're looking for. Because both of these are odd multiplicities, they cross through at 4 and -1. Notice the graph goes up, hits the graph, goes through, comes back down, hits the graph, goes through. So graph B is the one we're looking for there. It's a little bit advanced stuff on the second parts of these, but if you understand multiplicity, so maybe let's write it down. So for each factor, let's do it in large. So for multiplicity, meaning the exponent of each factor, right? So if it's even, we bounce. If it's odd, it goes through. We wrote this down on the last one, but just to reinforce it so that we understand why one of the graphs is the correct graph and the other one is not correct. Okay, and the last one is just interpreting our graph. So if we're looking at the graph of f of x, right? The function is increasing. It's asking increasing over which intervals. Choose all that apply. So increasing meaning it's going up as we go from left to right. So it's going up all in here, right? So from infinity to -9, check. I know it's hard to see there. And then from here, so that would be -7 to -3, check. And then from 1 to 4, check. -3 to 4, no, that's not correct, right? Because that's in this area here, that's decreasing. Oh wait, -3 to 4, that's actually this whole interval here. No, that's not true, because it's decreasing and increasing in there. So let's erase that. Okay, then it's increasing again here from, it looks like 2, 4, 6, 7 to infinity. So 7 to infinity. And just to check, 1, 2, 3, 4 intervals. 1, 2, 3, 4. We got them all. Okay, part B says the function f has local maxima at which x values. If there is more than one value, separate them with commas. Okay, so remember maxima. Maxima means the top of a hill. And minima means the bottom of a valley. So if we're looking at this, well, there's a top of a hill there, there's a top of a hill there, and there's a top of a hill there. So we should have 3 different ones, right? So it says to list them. So I think there's one at -9, right? That's this one. And then there's one at -3. And there's one at +4. Okay, and then when you guys are going, those of you who are planning to go to calculus at some point, this idea of minimas and maximas is very important. Calculus helps us to find that, and that they're important because, one, they change from increasing to decreasing or decreasing to increasing at those points. And two, they're the maximum values or minimum values in that region. So they can tell you, if you want to maximize profit, we'd be looking at the maxima. If we want to decrease our cost, if we're running a business, then we'd be looking at the minima. And another interesting thing is that, well, I shouldn't talk about the slope because we haven't talked about slope at one point, but the points, the slopes at those points would be 0. Okay, so part C, what is the sign of the leading coefficient? Okay, so that's when we're talking about end behavior, right? So if we're looking at end behavior for this graph, our end behavior is falling to the left, rising to the right. So we know that we have an odd, right? And it's also a positive. So this is positive. Okay, and then the last one asks about the possibility of the degree for f. So, okay, this kind of talks about our end behavior again. But more so, it talks about how many turns we have. So, which is kind of a little bit advanced, but not too bad. So for our part D, right? the first thing we have to do is we're going to look at the even odd, right? So this one is going to be an odd because it's falling left, rising right, it's opposite. So we know it's definitely odd. So we know all these even ones are out. Okay, now the other thing that we can talk about when we're talking about polynomials is that the degree is always at least one more than the amount of turns. So let's see how many turns we have. It goes from increasing to decreasing at that point. It turns here again, turns here again, it turns here again, it turns here again, it turns here again. So that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the degree is at least one more than the amount of turns. So it's got to be at least 7. It can't be 5 because there's too many turns. And it could possibly anything more than that. So technically this could be a 7 or a 9. Okay, so again, just to run this back around. First thing we're going to do is look at even or odd. So this is going to be determined by the end behavior, right? Because we know that the left and right side are opposites, we know this is an odd. Right? If they were going up, up, or down, down, then we know it to be even. Okay, so that's the first thing. So what we did was we crossed out all these even ones because we know that the degree can't be even. Okay, the next thing we did was we looked back and counted all our mins and maxes, minima and maxima. So we determined we had 6, 1, 2, 3, 4, 5, 6 of them. And we said that for the degree is at least one larger than the minimum, or the extremes. I should say extremes, which is the min and the max. Again, look, for those of you who are kind of confused about that, let's kind of talk about this. So let's say we have x to the 1, right? Our function is x to the 1. That's a linear, right? There's no terms. So 0, min, max, right? X squared, that's a parabola, right? There's going to be 1 min max, right? It turns right there from decreasing to increasing. And if it's negative, same idea, right? This is upside down. We're just going to have a max instead of a min. So x cubed looks like this, right? So x cubed, we have 2 terms. And then x to the 4th could possibly look like this. That's 1, 2, 3 terms. So again, there's always, the degree is at least 1 larger than the extremes, the mins and maxes. Okay, so that's kind of a lot to cover today. Hopefully you're okay with it. A lot of these ideas are advanced, but they're building towards giving you the foundations, at least, of what you're going to do in calculus. So it's really awesome. I wish that I had gone through this in Algebra 2. It would have made my life in calculus much, much easier. But yeah, they're just building foundations. So don't be